Welcome to the second part for section 2.3, and where we left off was question number 12. Now 12 appears at first glance to be a pretty formidable problem, but it truly is not that bad once you understand a few things. The directions read, use the properties of trigonometric functions to find the exact value. And there are several identities that are given throughout this section, mostly on pages 126 and then beginning at the bottom, or on page 128 and continuing on. And if we look at this particular problem, we have sine squared of an angle plus cosine squared of the exact same angle, and that happens to be one of the trigonometric identities, which, if you look in your book, simply equals 1. So anytime you have sine squared of an angle plus cosine squared of the same angle, that does equal the value of 1. Number 13. We need to find the exact value of the indicated trigonometric functions. Okay, the tangent of theta equals -10/7. And we are told theta is in quadrant 2. So we know that. We are asked what is the cosine of theta. Okay, first thing, let's deal with the sign. Is it positive or is it negative? All students, okay, the only ones that are positive in this quadrant is sine and cosecant. This is cosine, so we know our answer will have to be negative. Then what we're going to do is we're going to draw a triangle, a right triangle in particular. I like to put my theta right here. Now I know that the tangent represents the opposite leg over the adjacent leg. So the opposite leg is 10, the adjacent leg is 7. Now we completely ignore this sign here. We've already dealt with that. We don't need to worry about it anymore. But we do need to do a quick calculation of what would this hypotenuse be. Okay, 10 squared is 100. 7 squared is 49, equals c squared. So 149 will equal c squared, or c will equal the square root of 149, which I believe does not simplify any. And so now we can ask ourselves, cosine of theta is equal to what? Well, cosine is the adjacent leg over the hypotenuse. The adjacent leg is 7. The hypotenuse is square root of 149. We don't like this because it is has a radical in the denominator, so we rationalize that denominator and get 7 square root of 149 all over 149. It so happens that 7 and 149 will not simplify with each other, and so this is the final answer. Number 14 is a similar problem. It just has different values. Cosine of theta is equal to 7/25. And we are told that theta falls somewhere between 3 pi over 2 and 2 pi. Well, this is going to tell us which quadrant is it in. 3 pi over 2 and 2 pi, that's in the fourth quadrant right here. And what we are asking is, what is the cotangent of theta? Well, first thing we want to deal with is the sign. All students take calculus. The only thing that is positive here is cosine and secant, but we're looking for cotangent, so that means our sign will be negative. Secondly, we don't really know cotangent, or we can, but cotangent is the reciprocal of tangent, and tangent is opposite over adjacent. So what we need to do is we now need to draw our triangle, our right triangle. I'm going to put my theta here, just like always, and cosine says this is the adjacent over the hypotenuse. So the adjacent goes right there, the hypotenuse goes right there. Quick calculation right here. Okay, 725 squared is 625. And that will equal 49 plus a squared. Subtract 49 from both sides, and that is 576 equals a squared. Take the square root of both sides, and a equals 24. Now, of course, this would have been nice if we would have remembered there is the 7, 24, 25 Pythagorean triple. But, you know, it doesn't ever hurt to actually do the calculation. Okay, now cotangent is the reciprocal of tangent. Tangent is opposite over adjacent. So what we need is adjacent over opposite. The adjacent is 7. The opposite is 24. Now, we've already determined that it was negative from our previous analysis, and so the final answer is negative 7/24. Example number 15 concludes this type of problem. The sine of theta is equal to 1/2, and we are told that the secant of theta is less than 0. We want to find both the cosine of theta and the tangent of theta. Okay, first thing, we need to determine which quadrant we're in. Okay, sine of theta is positive, so that means it either has to be here in quadrant 1 or in quadrant 2. But this tells us the secant of theta is negative, which also means the cosine is negative. And between 1 and 2, the only place that that could occur is here in quadrant 2. So now we have to ask ourselves, in quadrant 2, what secant does cosine have? It's negative. In quadrant 2, what secant does tangent have? It's also negative. So we've taken care of the secants. We don't have to worry about those anymore. Now what we will do is we will draw our right triangle yet again. Notice there's two basic separate parts. We determine which quadrant it lies in, and then we draw our triangle. Now we're told the sine of theta is equal to 1/2. Well, sine is opposite over hypotenuse. So the opposite is 1, the hypotenuse is 2. Quick calculation using the Pythagorean theorem. 2 squared is 4, will equal 1 squared, which is 1, plus a squared. Subtract 1 from both sides, a squared equals 3, and so a would equal the square root of 3. So we have every piece of information that we need. Now we just fill it in. Cosine is the adjacent over the hypotenuse. The adjacent over the hypotenuse, or square root of 3 over 2. This will not simplify any further, so that is the answer for that. For tangent, that is the opposite over the adjacent. 1 over the adjacent, square root of 3. This we need to rationalize the denominator, so this becomes negative square root of 3 over 3. The next group asks us to use the even-odd properties to find the exact values of the expression and not to use a calculator. Now, even-odd simply deals with what happens to the secant. Does the negative come out front or does it not? And the simple rule is this: if you're talking cosine or secant of a negative angle, it's just like it's the cosine or the secant of that angle without the negative. All the others, you actually need to bring that negative out front. And that's not the technical way to say it, but that's perhaps the best way to learn it. So we have the sine of negative 30 degrees. Well, we've got a negative angle, and sine is the one where we do have to bring the negative out front. So this is equivalent to saying the negative sine of 30 degrees. And so we have looked at the sine of 30 degrees is 1/2, and so this would equal negative 1/2. And so the sine of negative 30 degrees is negative 1/2. Number 17, the cosine of 150 degrees, negative 150 degrees. Since this is cosine, the negative in essence, or we can think of it as it just sort of disappears. And so this is equivalent to the cosine of 150 degrees. We need to do a quick drawing here. 150 degrees puts it into this quadrant. So we do know that the secant here is negative because cosine is negative here in the second quadrant. More importantly, we know that the reference angle is 30 degrees because we're just lacking 30 degrees of getting the 180 degrees total. And so now we ask, what is the cosine of 30 degrees? Cosine of 30 degrees is the square root of 3 over 2. Now, even though we somewhat had this negative disappear at the beginning, it had to reappear because it happened to be in this particular quadrant, and cosine is negative in that case. Example number 18 finishes this group, and we're looking for what is the cosecant of negative pi over 2. Well, cosecant is one of those that the negative does or can be brought forward, so it becomes negative cosecant of pi over 2. And so let's see what happens here. Pi over 2 ends up being this angle right here. That's pi over 2. And we also know that cosecant is the reciprocal of sine. So the first thing we have to do is determine what is the sine of pi over 2. Well, the sine of pi over 2 happens to be 1. And that you can get in several different ways. The sine is 1. And so if this said sine, it would be negative 1. But since we need the reciprocal of that, it's negative 1 over 1, which still equals negative 1. And then the final example for this section is number 19. We are talking cosine of theta because f of theta is cosine of theta. F of a is equal to 1/5. We are asked what is the exact value of f of the opposite of a. Well, cosine. Since we're talking cosine here, the opposite of a, and we can sort of think of it that that negative just disappears. And so what we're asking is, what is the f of a? Because since it's cosine, this negative really doesn't play a part. And of course we know f of a is 1/5, and that is the final answer for number 19.